which is called curve fitting, and we're going to answer the question, how can I write the equation? So question 92 says, Mitchell was helping his friends work on his algebra homework. They were trying to write the equation of the line that passes through the points 5,15 and 3,7. Suddenly, Mitchell had an idea about finding linear equations. Look, he exclaimed. We know that the line can be written in the form y equals mx plus b. So we spent can you quit talking, Marcos? Thank you. So we spent a lot of time first semester talking about y equals mx plus b. The graph of it is a line, right? So we also know that the points 5,15 and 3,7 have to make the equation true. So we can substitute in these 2 points to create a system of equations. When we solve that, we'll know the values of m and b, and we'll have our equation. Part A, what is Mitchell talking about? Use his method to write the equation of the line through the points 5,15 and 3,7. Okay, so the point 5,15, I want you to label them x and y. And then the point 3,7, I want you to label them x and y. Okay, so both of the points have a value for x and a value for y. We're going to take those 2 numbers and we're going to plug them into the equation y equals mx plus b. The y is going to go here and the x is going to go here. Okay, so here's the first one. Here's the first equation. We take that 15, plug it in for y. Take that 5, plug it in for x, and we fill in the equal sign and the plus b. The second equation uses the second point. So we take that 7, plug it in for y. We take that 3, plug it in for x, fill in the equals and the plus b. Okay? Now we have 2 equations, right? Just like when we're doing systems. 2 equations, and there's a couple different ways to solve our systems, right? When you're solving systems, you can either use substitution, elimination, or the equal value methods. Right there. All right. So for this equation, for these 2 equations, our b's are almost opposites, right? They're both the same right now. We have plus b and we have plus b. So to get them to be opposites, I'm going to take that first equation and multiply everything times -1. So the 15 becomes -15, the 5m becomes -5m, and the plus b becomes minus b. Okay? Now my b's are opposites. They're going to eliminate. Right? If you want to slash them out, you can slash them out. Some people like to do that. Okay? Everything else we're going to combine. So 7 minus 15 is going to get us to -8. 3m minus 5m is -2m. And then what's the inverse operation of multiplying by -2? So we're going to divide both sides by -2. And we get m equals 4. So we've solved for our first variable. Now we take that value, that 4, and we can plug it into either of these 2 original equations. Apparently I liked the first one better, the second one better. I plugged it into the second one. So I had 7 equals 3 times 4, the number I plugged in, plus b. 3 times 4 is 12, so I subtracted 12 from both sides, and I get b equals -5. Once you have a value for m and a value for b, you can plug it into the slope-intercept form. So you have y equals 4x minus 5. All right, so this is a different method than what we learned all first semester. All first semester, they had us find the slope using the slope formula, then plugging in one of the points and solving for b, and then filling in this equation of slope-intercept. Okay? Question is, does this work? Bless you. So question B says, will Mitchell's method work to write the equation of the line through any 2 points? And the answer is yes, it will work, except one time, or one instance, is when you have vertical lines. Okay, if you're going to have vertical lines, it's not going to work. It only works when your line is sloped or horizontal. Okay, we're going to skip question 93. Just write SKIP, skip. And we're going to jump down to question 94. All right, so question 94 says, Mitchell thought that maybe his method from problem 92 could be used to write equations of exponential functions. Mitchell wondered if he could write the equation of the exponential function that passed through the points 2, 144, and 6, 725. So guess what we're going to label these 2 points? X and Y, right? So this one's our X, this one's our Y, this one's our X, this one's our Y. Okay? So for part A, it just says, what is the general form of an exponential function that has an asymptote at y equals 0? So here's the equation we've been working with, right? Y equals AB to the power of X. A is what? Starting value. B is our multiplier, or whatever our increase or our decrease is, okay? But notice that this equation has an X in it and a Y in it. Just like slope-intercept form, right? There's an X here, there's a Y here. So we're going to do the same thing. We're going to plug in our Y and our X. We're going to plug in our Y and our X. And we're going to see if we can solve for A and B, okay? So let's, part B says, use the 2 points that you know to create a system of equations. So for the first one, we're going to take the 144, plug it in for Y. We're going to take the 2, plug it in for the exponent right here for X. Okay? I just plugged the 2 numbers in here and here. Then I did it for the second point. For the second point, we have a 729 going in for the Y. And we have a 6 going in for the exponent right here. So here's our 2 equations. Looks a little bit different than the slope-intercept one, but we're just plugging in for the X and the Y, okay? This problem continues at the top of page 19. So at the top of page 19, somebody needs to turn their phone off. All right. Question C, what are the values of A and B that make your equation true? Be sure to clearly show your answer. So the first thing we want to do is we want to change this equation to get the A by itself. Then we want to change this equation to get the A by itself. So right here, the A is being multiplied by B squared. So the inverse operation is to divide by B squared. Okay? Same thing here. The A is being multiplied by B to the 6th power. So the inverse operation is to divide by B to the 6th power. Okay? These 2 equations are both set equal to what? A. This one's set equal to A. This one's set equal to A. So instead of using elimination on this one, we're going to use equal values method. Okay? Equal values method looks like this. We're going to take the 144 over B squared and set it equal to the 729 over B to the 6th. Okay? We've got our exponents in there, our powers. We're going to see what to do with them in just a second. All right, so the first thing we're going to do, since we have a proportion, is we're going to do something called the cross product, where we're going to take the 729 and multiply it by B squared. That's right here. Then we're going to take the 144 and multiply it by B to the 6th. So that's this direction. Set them equal to each other. All right. Now we're going to divide both sides by the 144 and the B squared. Okay. So on the left side, the B squareds are going to cancel. And on the right side, the B to the 144s are going to cancel. Okay. So b squared goes into b to the 6th. How many times? It's a tricky question. Actually, you want to take this power and subtract this power. So it's b to the 4th. So we're going to have b to the 4th, and then we're going to have that fraction, 729 over 144. Okay, so just write it as a fraction, 729 over 144. Now, what is the inverse operation of something going to the 4th power? Not square rooting, but you're so close. You're going to take the 4th root. So it's a square root symbol, but instead of having 2 there or nothing there, you're going to take the 4th root. All right? So for this operation, you're going to need your calculator. And if you don't have your own personal calculator, you're going to use Desmos.com. Okay? But here's how you use your calculator. For the 4th root, you have to type the 4 first. You have to hit the 2nd and make the calculator make sure it says the xth root. Then you're going to type this fraction, 729 over 144. So I'm going to use parentheses. So I'm going to type 729 divided by the 144. Let the calculator do all the work. Hit the equal sign. And it spits out 1.5. Whoops, where did it go? There it goes. And it spits out the answer. So the answer for B is 1.5. So we've got our first variable B. Now we need to get our A. So to get A, you can either choose this first equation or this second equation. I think the first one looks slightly easier, right? Okay, slightly easier. I'm going to plug in the 144 over 1.5 squared. And again, I'm going to let the calculator do all my work. I'm not going to try and figure it out. I'm going to say 144 divided by this denominator of 1.5 squared. So I'm going to type in 1.5 and square it. Make sure I put it in the parentheses. So I'm telling the calculator to do that exponent first. Hit the equal sign. And I got 64. Okay, so my B, my multiplier, is 1.5. And my A, my starting point, or my starting value, is 64. So question D says, using your values for A and B, write the equation for the function that goes through that point. So the A, or the 64, gets plugged in for the A right there. And the B of 1.5 gets plugged in where the B goes. Okay? All right. Now we're going to try 2 more. Question 95 says, write the equation of an exponential function that passes through each pair of the point. So we're going to do this 2 more times. That's all it wants you to do for parts A and B. Okay? So the first one, your point -1, -2, here's your x and your y. And your second point, 3, -162, here's your x and here's your y. Okay? All right. So let's get our first equation. So we're going to plug in -2 for y. We're going to plug in -1 for the exponent. And then we're going to solve for A. So if A is being multiplied by B to the -1st, we're going to divide by B to the -1st. Then we're going to do it with our second point. We're going to plug in -162 for the y. We're going to plug in 3 for the exponent. And then if A is being multiplied by B to the 3rd, we're going to divide by B to the 3rd. Okay, so we have this equation and this equation, both set equal to A. So the equal values method says we can set them equal to each other. So we've got our -2 being divided by B to the -1st. We've got our -162 being divided by B to the 3rd. So from this proportion, we're going to do a cross product. So we go this way and this way, kind of making an X. Okay? So -2 times B to the 3rd and -162 times B to the -1st. So we're going to divide both sides by -2, and we're going to divide both sides by B to the -1st. Well, some people think that when you have a negative exponent, you would subtract it, but you're actually going to add it so that it moves up to the numerator. So this b to the third actually becomes